3 is a magic number. Oh, yes, it is. It's a magic number. And I'm not just saying that because it's a really cool Schoolhouse Rock song. 3 is really an effective number. It's used in screenwriting with the 3-act structure and the 3 primary characters. And we all know that a table with 4 legs is not as stable as a table with 3 legs, known as a tripod, right? 3 is also an approximation of pi. It's also the very first Fermat prime. It's used in photography with the rule of 3, where the subject of the photo is placed in the left or the right third of the frame. And finally, most songs use the structure of 3 with the chorus, the verse, and the bridge. But it can also make a major chord with 3 keys apart. 3 is a magic number. The history of math is our intellectual foundation to understanding science. Science. Beautiful, awesome, wonderful science. It's the creative foundation to our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. Obviously, number 3 is an effective number, but it's not magical. Numerologists think that it represents creativity, energy, and possibility as based on the past, the present, and the future. But honestly, numerology is a pseudoscience. It's not based on anything that can be scientifically proven, despite what some people would like to think. They think that pseudoscience is founded in the scientific method, and truth be told, it is not. And the same goes for math. There are some mathematical equations that are completely unsolvable and cannot be proved, despite what some inexperienced mathematicians claim to have miraculously solved. And some of these problems have been around for thousands of years. And even so, they still have not been proved. They're unprovable based on the parameters that they are presented in. This activity of solving unsolvable problems using basic non-rigorous, non-peer-reviewed mathematics is known as pseudomathematics, also known as mathematical crankery. There have been pseudo-mathematical applications applied to the Millennium Problems, P versus NP problem, Fermat's last theorem, the Collats Conjecture, and the 3 popular ones, which are the squaring of the circle, the doubling of the cube, and the trisecting of the angle. And those who have claimed to have solved these using non-rigorous, non-peer-reviewed processes are known as pseudo-mathematicians, or as mathematical cranks. Not to be confused with cranky mathematicians, because we've all met some of those, and some of those are actually really good mathematicians. In 1851, a gentleman by the name of John R. Parker published a book called The Quadrature of the Circle. The story is actually in this book by Peter Buckman. It's really a good book. And in this book, he claimed to have solved the squaring of the circle. The thing is, the squaring of the circle is impossible to solve. The challenge goes like this. You're supposed to find the area of a circle that equals the area of a square. Oh, and you're supposed to be using a compass and a straight edge. Those are the parameters. The problem with this is that in order to find the area of a circle, you need the value of pi. And pi is an irrational number, it's transcendental, which means it's non-algebraic and it is non-constructible. The point of me telling you this is because John Parker held steadfast to this belief that he had solved the squaring of the circle despite what academic mathematicians were telling him and showing him where the flaws were in his mathematics. Another impossible problem that I really love is called the doubling of the cube. And I actually talk about this in podcast number 9 called Nigel Tufnell and the Doubling of the Cube. And I have it on my blog at my website, mathsciencehistory.com, where I also post the video of Nigel Tufnell singing Stonehenge. And the reason why is because nothing says math is important like watching an 18-inch Stonehenge figure drop from the ceiling during a rock concert. So the doubling of the cube has been proposed since about 400 BCE. So it's over 2,000 years old, and it's still unsolvable using the parameters of a compass and a straight edge. Many pseudo-mathematicians had been sending solutions to universities showing that they had proved the doubling of the cube and the squaring of the circle and the trisecting of the angle. Well, by the 17th century, the French Academy just said, enough. They are no longer going to be evaluating these solved problems because basically it's a waste of their time. Now, the cool thing about this, this was the 17th century, this was like one of the first times that academia and academic mathematicians recognized that pseudomathematics was really prevalent in society. I want to take a short break, and I want to send a big thank you to BetterHelp for sponsoring this podcast. If you could please give a listen to a word from today's Math Science History sponsor, who helps to keep this podcast up and running. Battling with mental and emotional challenges is not an anomaly. Sometimes we all need help, and I love how in these recent years the search for mental wellness has been destigmatized. And no doubt these last 2 years have been hard and have left us holding in a lot of grief, wondering what exactly is interfering with our happiness. BetterHelp, that's Better H-E-L-P, is here to help you. BetterHelp is a wonderful online international platform that provides counseling for depression, stress, anxiety, and grief, to name a few. Keep in mind, this is not a crisis line and it's not self-help. BetterHelp is professional counseling through an online, safe, secure, and confidential platform. When you sign up, you can start communicating with a counselor within 48 hours. And because it's online, you don't have to wait in a waiting room. You can message your counselor at any time and you can schedule weekly and video phone sessions. Additionally, their counselors are affordable. They offer financial aid and it's free to switch counselors if you need to. Who wouldn't want to start living a happier life today? As my listener, you will get 10% off your first month by visiting betterhelp.com/listener. Another impossible problem is called the Collats Conjecture. And the challenge goes like this. With the Collats Conjecture, you pick a number, any number. I'm going to pick the number 42 because it's the ultimate answer to the ultimate question. In this challenge, if the number is even, you divide it by 2, and if the number is odd, you multiply it by 3 and add 1. So, since I'm starting with the number 42, I'm going to divide that by 2. Divide that by 2, I get 21. It's an odd number, so I multiply it by 3 and I add 1. Then I get 64. Well, 64 is an even number, so I divide that by 2 and I get 32. 32 is also even, so I divide that by 2, I get 16. 16 is also even, so I divide that by 2 and I get 8. 8 by 2, which gives me 4. I divide 4 by 2, which gives me 2. I divide 2 by 2, which gives me 1. But 1 is an odd number, so I multiply it by 3 and add 1. I have 4, so I divide 4 by 2, which gives me 2. I then divide 2 by 2, which gives me 1, and then I have 1 again. As a result, I'm now stuck in a 4-2-1 loop. I just want to clarify that this doesn't mean that anybody who attempts to solve an impossible problem is a pseudo-mathematician. On the contrary, on September 8th, 2019, Dr. Terence Tao presented a partial proof showing that for the Collats Conjecture, it was almost true for almost all numbers. But even he knew that it was still an impossible problem to solve, and the problem still remains unsolved. So let's talk about the history of pseudo-mathematics. The word pseudo is actually founded in Greek etymology, and it means basically fake. So the word pseudoscience was first being used around the 17th century among scientists to show the relationship between religion and imperialism. The word was first published in 1796 when historian James Pettit Andrew referred to alchemy as this fantastical pseudoscience, which honestly, I think alchemy is really cool because it opened the door to chemistry, which is one of the most wonderful sciences to learn. The word pseudomathematician was first published in 1915 by the great mathematician Augustus de Morgan in his book A Budget of Paradoxes. He then went on to define the pseudomathematician as a person who handles mathematics like the monkey handles the razor. And the analogy goes is the monkey watches the human shave himself, and so the monkey takes the razor, tries to shave himself the same way, but doesn't know how to hold the razor, and in the process ends up slicing his throat. Augustus de Morgan then went on to throw James Smith, the pseudo-mathematician James Smith, under the bus because James Smith adamantly published that the value of pi was 3 1/8 exactly. So, the point of the story is, the label pseudo-mathematician is the ultimate burn. So how do we define a true pseudo-mathematician? After all, what's wrong with someone being completely enthusiastic about mathematics? Well, let's talk about peer review. Peer review is the process of sharing your work with your peers. So in academia, they share it with other academics. For those who have claimed to have solved these unsolvable problems, the work is reviewed, evaluated, and duplicated by other mathematical peers who can validate that the work is founded on rigorous mathematics and logic. What is wonderful about the process of peer review is that it opens the door to communication. It opens the door for other scientists, other mathematics, other historians, and other academics to talk about these findings and either build upon them or find out that they are false. If the work is submitted without peer review, if someone claims they have solved something as an unsolvable problem, but it has not gone through the process of peer review, then it is simply mathematical crankery. So back to Mr. Parker and his book, The Quadrature of the Circle. Peter Beckman, in his book, The History of Pi, which is a great book, by the way, I love this book, he goes on to write about Parker and how Parker, when his work was reviewed by other mathematicians and they showed the flaws in his work, Parker became very defensive and actually resorted to name-calling. And he actually said that these mathematicians were among the least competent to decide on any newly discovered principle. Don't get me wrong. There is nothing wrong with trying to solve the unsolvable. The most beautiful thing about mathematics is trying to solve those things that have been pondered for thousands of years. And by doing so, it can alter your viewpoint and change your perspective on the beauty of mathematics. These are puzzles. These unsolvable problems are puzzles. And the exciting thing about these unsolvable problems is that they can engage a community of other mathematicians and scientists and create a level of discourse that can be absolutely exciting. And you don't need an advanced degree to sit down and give it a go. And who knows? You might find yourself so enamored with mathematics that you may find yourself back in college earning a degree in something you never thought you'd learn before. You may find yourself veering one way to learn math, another way to learn physics, and yet another way to learn chemistry, or even find yourself sitting in a history class, realizing that there's so many wonderful things in the world to learn. That's the power of math, science, and history. Until next time, Carpe diem. If you enjoyed this podcast and would like to hear an early release of my podcasts, as well as podcasts with bonus mathematics and science, please head on over to patreon.com/mathsciencehistory and sign up to be a patron. As a patron, you can receive all kinds of additional benefits, including additional math and science on my podcasts, your patron name listed as a supporter at mathsciencehistory.com, exclusive posts about math, science, and history, and patron acknowledgments on my YouTube videos, as well as early access to ad-free content. So come on over to patreon.com/mathsciencehistory and join the community. Until next time, carpe diem.